All right. So the first thing you should see, there was a slight mistake. I corrected it on this worksheet. It said chapter 9, and it should really be chapter 10. So you can correct that. We didn't cover chapter 9. All right. In chapter 10, we're looking at inflows and outflows, and we're looking at transaction exposure, and we're measuring that exposure using something called a value at risk methodology. All right. So the first thing we want to see is that if you have both inflows and outflows, there's a good chance that there's might be a natural hedge, especially with currencies that are highly correlated. Okay. So to get the exact number, we'd have to look at a correlation coefficient, and we're not really going to do that exactly. So instead, what we're going to do is go ahead and look at this on sort of a conceptualized basis. So what we see here is that if we have inflows, and inflows are like accounts receivables, okay? That's what we've looked at so far, but it could be something else. So we just call them net inflows, okay? So if we have net inflows of 20 million euros, and we have net outflows for next month of 15 million pounds, then we want to kind of look at this in terms of a dollar amount of exposure. Since the exchange rate right now is around $1.22 for the euro, so if each euro is worth $1.22, then 20 million euros would be equivalent to $24.4 million. And if we have 15 million pounds, but each pound's trading at $1.31, then 15 million pounds would be equivalent to around $19.65 million. And from that, we can subtract the two. And since inflows is larger than outflows, we basically have a net inflow equivalent to around $4.75 million. Okay. So we would have an inflow around 4.75 million. Now the next question is a little bit trickier. It says, let's assume that the euro and pound are highly correlated in their movements against the dollar. So correlation coefficient probably won't be perfectly equal to 1, but it might be as high as 0.9 or 0.85. And basically what that means is when the euro strengthens against the dollar, the pound tends to strengthen against the dollar. And if the euro weakens against the dollar, the pound weakens against the dollar. Okay? If they were perfectly correlated, the percentage changes would be the same. If they're highly correlated, it means a lot of times they move in the same direction. And the degree of correlation goes from -1 to 1. So if it's positive, it's basically going from 0 to 1. The closer to 1, the higher the correlation. If the euro and pound are highly correlated and the US dollar weakens, that is, both foreign currencies strengthen. Now you can kind of see it. If the euro were to strengthen from, say, $1.22, and let's just assume it goes up, say, 5%. If it went up 5%, then the euro would be at $1.28.1, and our inflows would be worth more. Okay? So the inflows would be worth more, because the euro strengthened and the dollar weakened. Okay. And inflows worth more would make us happy in some sense. But also, let's suppose that they were perfectly correlated and the pound also went up 5% from $1.31. If the pound also went up 5%, that means the new exchange rate would be $1.3755 per pound. And guess what would happen? Our outflows would also go up. Now, our outflows were $19.65 million before. And now if they went up 5%, it means the outflow, or what we owe, okay, we owe 15 million pounds. What we owe costs more. And that would make us sad, okay? So paying more is not good, but receiving more is good. So we kind of look, in this case though, if in fact the dollar weakened, what would the net effect on this company be? Well, the net effect, since inflows from a dollar perspective are worth more than the outflows, then essentially the net benefit would be positive. They would benefit from the exchange rate movement, because both things would be occurring at the same time. But since we have more foreign currency coming in terms of dollars than we have foreign currency going out in terms of dollars, then the dollar weakening or foreign currency strengthening would have a net benefit to us. Let's see if there's any questions after that. All right, does that kind of make sense? Any questions so far? All right, seeing no questions. Let's go back to this problem number 12. I'm going to just try to make a little more room for myself. Doesn't really like abrupt changes. All right, let's go ahead and look at number 12 then. The U.S. company has just purchased a large quantity of parts for 2 million euros. So this is a payment or an outflow. And here we are on day 0. The payment we have to make is going to be in 90 days. In 90 days, we're going to have to purchase 2 million euros. Okay. What we don't know is what that euro will cost us. Okay. What we do know is the exchange rate today is $1.24 per euro, but we've seen the euro bounce up and down. We just don't know where it will be in the future in 90 days. Now, we expect it, and we use that term loosely, but we expect it, or our best guess is that there will be, on average, no change, meaning we have sort of a neutral outlook. Okay. Most likely it will be higher or lower. We just don't know what direction. We're assigning equal probability it could go up as it could go down. We have no preferential bias. It's kind of like saying when we throw the 100 coins up, we expect 50 heads to come up. It's not really what we mean. It's just the terminology that we use. So a 0% change, that means we basically expect the euro to be trading somewhere around $1.24 90 days from now. Okay. Now, we recognize that there is some variation in this guess. And so just like with the coins, if we wanted to be more accurate, we would say, hey, I expect 50 tails to come up with a standard deviation of 5. And by saying that, you would really be conveying more information. Now here, we're saying, hey, we expect a 0% change, but the standard deviation is 6% over the 90-day period. So the annual standard deviation is 12, and most people would talk about it in annualized terms. But we can convert an annual standard deviation into a periodic standard deviation. So the standard deviation of 6 means we wouldn't be surprised if it went up 6% or down 6%. In fact, up 6% and down 6% would encompass about 68% of the outcomes. So given that, if we want to find a value at risk, but let's go ahead and answer the first question. The first question says, what's the expected dollar cost of the 2 million euros? Well, since we expect no change in the value of the currency, the 2 million euros would cost us around $2.48 million, okay? Because we expected the spot rate to have no change. Okay? Now we want to figure out the worst case scenario. Okay? That is, what's sort of our 95% worst case? Well, since this is a payment, what's bad is if the euro would strengthen. Okay? So we want to put this as sort of our worst case. Now, the worst case is obviously it could double or triple, but that's not likely to happen very often over the next 90 days. In fact, very infrequently. Sort of like throwing up 100 coins, and is it possible to have, no tails come up? They all be heads. Yes, but it's very unlikely. Okay? Almost to the point we don't even consider it possible. Okay? So if we want to look, though, at a 5% worst case scenario, that is, we want to look at a 95% value at risk. There's only a 5% chance. And remember, on a one-sided tail, 95% of the observations will fall below 1.65 standard deviations from the mean. Okay? So if we look at 1.65 standard deviations, and our standard deviation is 6%, then 1.65 standard deviations would be equivalent to around 9.9%. Okay? So we're fairly certain over the next 90 days that this currency won't increase by more than 9.9%. Now, what's the corresponding value to that? Well, $1.24 increasing by 9.9% would be $1.36,276. So you could write it as $1.36,3. Okay. So right now we see the euro trading at $1.24, but we don't expect that it will go up above $1.36,3 per euro. And we have about a 95% confidence level with that occurring. Okay. Now, if we want to figure out what is the actual value at risk, we could do it a couple ways, and I'll do it 2 ways here, but I'll show you the easiest way first. If you want to look at the easiest way, the 95% value at risk is just to take the expected value, which is 2.48 million. Oops. Take the expected value at 2.48 million and multiply it by 1.65 standard deviations. Okay. So the worst case scenario is if you take 0.06 times 1.65, the worst case scenario is not only will the currency appreciate by 9.9%, but we'll end up paying 9.9% more. And 9.9% more than 2.48 million is $245,520. Alternatively, if you wanted to figure out, oops, let me go down here. If you wanted to figure out sort of the longer way would look like this. Here's our expected cost, and our expected cost was $2.48 million. So our expected cost was the euro trading at $1.24, which meant our expected cost is 2.48 million. And our worst case is the euro trading at $1.36,276, which means the worst case cost is $2,725,520. And the value at risk is just the difference between those. And you'll notice the difference between those is $245,520. Okay. So this is sort of the easier way to figure it out. Look at your expected cost and just multiply it by the percentage change that you expect to happen under a worst case scenario. Or you can sort of do it the long way. It's just a distributive property of multiplication. All right, let's see if there's any questions from that. All right, any questions so far from Chapter 10 review? All right, if there are no questions, let's go back and look at the top of this page. I'll give you a second. And let's look at Chapter 5, which is forward and futures contracts. All right, let's go ahead and look. If you remember, a couple things from Chapter 5 that I wanted you to know. I wanted you to know what's the difference between a forward and a futures contract. I can't remember the exact page, but I can look it up. Let's see. Difference between forwards and futures, page 139. And it talks about all the differences, mostly in terms of size of the contract, the delivery date, participants, the marketplace, and so forth. Okay. The two main differences are size. So forward contracts are large transactions, usually 1 million or 10 million, somewhere in that range as a minimum, depending on the bank. Futures contracts are smaller, 125,000 euros, 62,500 pounds. In different currencies have different amounts. There's also mini contracts out there as well, so they can even get down a little smaller. The other difference between the two is how they trade. Forward contracts are negotiated between you and the bank. They're tailored to individual needs, whereas futures contracts trade on an exchange. And there is a counterparty that conducts the transaction. With forward contracts, they do not trade on the exchange. They're what are called over-the-counter transactions, and there is counterparty risk. If your bank goes out of business, there's no one to make up the other side of the trade, and so you're left stranded. Other than that, you can sort of read through some of the differences. Main thing we need to figure out from chapter 5 is how to price forward contracts, and the formula we use, forward rate is equal to the spot rate times 1 plus the premium. Okay. So that if you looked at it, okay, you could solve for the premium. I often solve for the premium like this: forward divided by spot minus 1. But you could also solve for the premium, forward minus spot over spot. It's just an algebraic manipulation. Okay. The other thing we need to look at is, because the premium, which is calculated as forward minus spot, forward divided by spot minus 1, what we saw, it's approximately equal to the difference in interest rates. Difference in interest rates between the US dollar and the foreign currency. Okay. And this is important because this later gets us to interest rate parity and covered interest arbitrage. So because the interest rates are usually quoted on an annualized basis, we need to know the difference between periodic premiums and annualized premiums. So if we have a periodic premium, we need to convert it to an annualized premium, because the interest rates are often given on an annualized basis. All right, let's go ahead and look at the first question. If the 180-day forward rate is equal to $1.25 per euro, and the spot rate is equal to $1.24, then what is the annualized forward premium or discount on the euro? Well, the periodic premium is equal to forward divided by spot minus 1. So if we take $1.25 and divide it by $1.24 and subtract 1 from it, we're going to get 0.008, or 0.8%. Now remember, that's the periodic premium. In order to find the annualized premium, we take the periodic premium and multiply it by M, which is a multiplier. This is the number of 180-day periods in 1 year. And in our case, a year is defined by 360 days. So our annualized premium would be equal to the periodic premium. And in 360 days, there are 280-day periods. So I'm going to take that, multiply it by 2, and I'm going to get 1.6%. Knowing the annualized premium will help us figure out approximately what interest rates are in another country. So if US interest rates are 3%, if US interest rates are 3%, then we can figure out interest rates on the euro, because we know the difference should be about 1.6%. Okay. What does that mean? Interest rates on the euro should be around 1.4% if US interest rates are 3% and the premium is 1.6%. All right, let's stop here and see if there's any questions. Questions? All right. We got a 90-day forward rate on the peso at 0.055 and a spot rate at 0.56. What this means is that it's cheaper to buy pesos 90 days from now than it is to buy pesos today. How is that possible? Well, we'll see in just a second. So the 90-day premium.
Are we supposed to be able to see your screen right now?
Oh, you're not seeing my screen? Sorry.
No.
I forgot to reshare it. Thank you.
Yep.
All right, how about now?
Yes.
Okay. So the 90-day forward rate on the Mexican peso is 0.55 cents and spot rate 0.56. So the premium over 90 days should be equal to about negative 1.8%. What that would be called, even though the P is used, this would be called a forward discount. Okay. So a negative premium is referred to as a discount. So we'd call it a 1.8% forward discount. Now, knowing that, let's go ahead and look. Oops. Let's erase this. Knowing that is the 90-day premium, let's go ahead and find the annualized premium. We need to take the 90-day premium and multiply it by the number of 90-day periods in a year. So in order to annualize that, it would be 7.2%. All right. So if we know the annualized premium, And we know interest rates in the US are 3%. We could figure out interest rates on the peso. And what we would find, if you work the mathematics out, if you work the mathematics out, the interest rate on the Mexican peso would be around 10.2% on an annualized basis. All right, so when interest rates in the foreign currency are higher than interest rates on the US dollar, the foreign currency will sell at a forward discount. Oops. There. All right, so whether or not the currency sells at a premium or a discount is not really affected by supply and demand. Instead, it's affected by interest rates. And we actually know that to be true because we've looked at the next chapter and we've studied interest rate parity and covered interest arbitrage. All right, let's see if there's any questions. Any questions on 3 and 4? All right, moving on. Let's look at number 5. We can also, knowing this relationship, figure out what a futures contract will be trading on at a different point in time. Okay. All right. If the spot rate today, so this was probably, today is April 15th, 2019. So this was from last year. Okay. If the spot rate today is $1.25, oh, this must have been 2018. April 2018. Okay. The spot rate today on the euro is $1.25. And the April 2019 futures contract, so a 1-year futures, was trading at $1.27. So we're in 2018. We've got a 1-year futures contract. And we want to see what will happen as we move through time. Okay. So if we're already in April of 2018, if we go ahead to October of 2018, and the spot rate has moved to $1.33 in October, then what will happen to the futures price? Okay. So we've moved part of the way through the futures contract. The currency has gone up and down, and it finished higher. Okay. And the new futures price will be a function of the new spot price and the premium. Okay. Now we want to be careful here because we got to figure out how much time is left between October and April. So October, November, December, January, February, March, April. So we have 6 months left on the contract. Okay. If the annualized premium is 2%, then we have to find the periodic premium. But we have to know what the multiplier is. Okay. Since this is a 6-month interval, the multiplier is going to be 2. And we need to figure out what the periodic premium is. If the annualized premium is 2%, then the periodic premium is going to be 1%. So the new futures price is dependent upon the spot price that changed over time. It changed to $1.33. And whatever happened to interest rates over that time period. Okay. So the difference in interest rates was around 2% on an annualized basis. So if the spot rate is $1.33 in October, the futures price should be now $1.3433. Okay. So basically, most of the time, unless interest rates change dramatically, when the spot rate goes up, so does the futures price. When the spot rate goes down, so does the futures price. Now, it's not perfectly aligned because time has passed. But the predominant factor besides time is what happens to the spot price. Okay. All right. The other thing we talked about briefly in chapter 5, hold on before I get going. All right, any questions on forward rates over time? Forward rates over time? All right. Let's go back and look then at one other thing. We already talked about futures being different from forwards. How are they similar? Blah, blah. Okay. Call options. We just talked briefly about these. Call options are the right to buy, but not obligation. And put options are the right. Ooh, it doesn't like that.
We can't see your screen.
Oh, yeah. To sell. Forgot about screen. All right. Maybe we're screen sharing now. All right. So call options are the right to buy. Put options are the right to sell. Okay. So if you think about it, if you have accounts payable and you're looking to buy currency, okay, the right to buy it at a specific price would be valuable. Okay. And that's what we're going to use to hedge accounts payable. If you have accounts receivable, it means currency is coming in. And put options would be nice because a put option gives you the right but not obligation to sell currency that you have coming in at some particular price called the exercise price. All right, other than that, we're not too worried about them. We'll pick them up later on. All right. Chapter 7, locational arbitrage, triangular arbitrage, and covered interest arbitrage. All right. We've done a few of these, but what we should see is while the exchange rates will not be exactly equal, they should be in some form of equilibrium. Okay? In this case, if they're too far out of equilibrium, you can use locational arbitrage to put them back into equilibrium. So what you'd want to do here is buy Swiss francs at Bank X. Okay. And with $100,000, figure out how many you can buy if each one costs you $1.10 too. Okay. So with $100,000, you can buy 90,744.1 Swiss francs. Ah. Okay. All right. Now, after you buy those Swiss francs, you want to immediately sell the Swiss francs to Bank Y. And you will receive the bid price. So if you have 90,744.1 and you can sell them at $1.10 you'll make a riskless profit around $181.50. Okay. What will happen? The more you buy at Bank X, the price will tick up. The more you sell to Bank Y, the bid price will tick down, and we'll have some equilibrium at probably around 1.103. They still won't be exactly the same, okay, but there will no longer be an opportunity for locational arbitrage. So locational arbitrage is just a way to quickly realign some of the inefficiencies. Questions?
Can you go back to that just for a second so I can take a picture of it?
Sure. On the screen share?
Yeah, that's perfect. I got it. I just wasn't done writing yet, but you can keep going.
No, it's fine. I'll give you a second. All right. So if we look at triangular arbitrage, this is a little simplified because it's ignoring the bid-ask spread. Okay. But it's good to get the idea in terms of review. Okay. So if we want to figure out what the cross rate should be between the Canadian dollar and the euro in terms of number of Canadian dollars per euro, okay, we've got A, B, and C. C is the cross rate. C is determined by taking A and dividing it by B. Okay. So if we want to figure out the cross rate, we know a euro is worth $1.193 and a Canadian dollar is worth 90 cents. Then that tells us essentially that the cross rate should be $1.3256 in terms of Canadian dollars per euro. If you have 100,000 to conduct triangular arbitrage, what's your profit from implementing this strategy? Well, you recognize that bank C is, since this is both the bid and the ask spread, I mean, there is no bid ask spread. This is the exchange rate you can buy or sell at. You certainly wouldn't want to buy euros with Canadian dollars because it would be too expensive. But you would like to sell euros to Bank C for Canadian dollars, okay? Because they're willing to give you 1.329 Canadian dollars, and they should be giving you about 1.326, okay? Now, that's the second part of the triangle. Okay. Since we have $100,000, the first thing we're going to want to do before we can sell euros to Bank C is to obtain them. So we're going to buy euros from Bank A at $1.193 per euro. Now remember, if we have $100,000, each euro is worth more than $1. So we should end up with less than 100,000 euros. And we end up with 83,822.3 euros. Okay. Now we can sell the euros to Bank C, the second part of our triangle, for Canadian dollars. They're going to give us 1.329. And if we have 83,822.3 euros, we'll end up with 111,399.8 Canadian dollars. Now we need to sell those Canadian dollars to Bank B for 90 cents. And if we sell those Canadian dollars for 90 cents, we'll end up with $100,259.85. Thus giving us a riskless profit at $259.85. What will happen? As you buy euros from A, the ask price will tick up. As you sell them to C for Canadian dollars, that bid price will tick down. And as you sell the Canadian back for US dollars, okay, that bid price that they give you will tick down and eventually will be in equilibrium. I'll give you a second. All right, let's see if there's any questions on number 7.
So to get the first side of the triangle, you took the 100,000 times the reciprocal of 1.193, right?
Sure. Well, yeah, of course. Or just take 100. Here, let me write it out.
Or divide, yeah.
Yes.
Okay.
Hold on. So let me see if I can. All right. So really what you had was $100,000, and you wanted to know how many euros can I get if they're charging me $1.193 per euro. That's sort of the easiest way to look at it. Okay. And of course, you take 100,000 divided by 1.193. But yes, taking the reciprocal would work as well. You're converting a direct quote into an indirect quote.
Thank you.
All right. Okay. Let's go ahead and drop down to number 9 so I don't lose out on time. We can come back to 8 if we have time. 8's the exact same thing. Okay. All right. If we look at number 9, what we want to look at is check first. Check first to see if interest rate parity exists. Okay. In order for interest rate parity to exist, the premium, as defined by forward over spot minus 1, should be equal to the difference in interest rates. And if that's true, then you'll be what's on the interest rate parity line, because the x-axis is showing you the premium as forward divided by spot minus 1, and the y-axis is showing you the difference in interest rates. Now remember, if you're somewhere below the interest rate parity line, the US investor can use covered interest arbitrage. If you're above the line, the foreign investor can use covered interest arbitrage. So let's go ahead and look. If we look at the forward rate relative to the spot rate, so 0.652 divided by 0.645 minus 1, we can see that this is 1.09%. If we look at the difference in interest rates, we can see that this is 0.5%, and they're not equal. Okay. Oops. No. Okay. So they're not equal. So now we've got to figure out who can use covered interest arbitrage. If we go over about 1.1% and up about 0.5%, we're going to be down here below the line. And so the US investor can use covered interest arbitrage. So what we need to look at is what is the profit, and it's the additional profit that we're interested in. So what we can see is if a US investor had $100,000, then at the end of 1 year, by investing it locally at 3.6%, they'd have $103,600. If they used covered interest arbitrage, they would take the $100,000 and convert it into New Zealand dollars at the spot rate. And the spot rate was
How did you get 1.09%?
oh, is that not right? The forward rate is 0.652 and the spot rate is 0.645. 0.652 divided by 0.645 minus 1. I got 1.085 to round it up to 1.09.
Yeah. Okay. Sorry.
No, it's fine. Glad someone's still there. All right. So using covered interest arbitrage, take the 100,000, convert it to New Zealand dollars at the spot rate. And the spot rate is 0.645. So we would have $155,039 New Zealand dollars. Okay. And I just took 100,000 divided by 0.645. Now they'll only earn 3.1% on their money. So at the end of 1 year, they'll have 159,000 845 New Zealand dollars. Now back on day 0, they locked in a forward rate. Oops. To sell New Zealand dollars. And the forward rate they locked in was 0.652. And I'm running out of room. Okay. So in 1 year, the 159,845 New Zealand dollars at 0.652 US dollars would be worth 104,219. That's giving them an additional profit $619. The next question says, would covered interest arbitrage work for a New Zealand investor with 100,000 New Zealand dollars to invest? The answer is no. Even though they might be attracted by the higher interest rate, so they'd take their New Zealand dollars, convert them into US dollars, earn the higher interest rate. But the problem is when they convert them back into New Zealand dollars, you can see that the forward premium represents a strengthening of the New Zealand dollar. That means it would be a weakening of the US dollar. So while they'd earn 0.5% more in terms of interest rates, they'd lose about 1% in terms of the currency when they converted it back into US dollars. So they'd actually be worse off. So the idea is covered interest arbitrage only works in one direction.
Wait, where did you get the 104,219 from?
Okay. So at the end of 1 year, the 155,039 New Zealand dollars earned 3.1% interest. So at the end of 1 year, they had 159,845 New Zealand dollars, which they could sell at the forward rate of 0.652.
Okay, got it. Thank you.
So the New Zealand dollars they had, I ran out of room. The New Zealand dollars they had in 1 year, they would lock in to sell at that forward rate. And so while they're earning 0.5% less in terms of interest, that shows up right here. They actually pick up 1% in terms of the currency appreciation, a little bit more than that. So they end up being better off by about 0.5%. All right. All right. We're getting close to the end. I hate to try to not stop, make sure. Any questions on sort of the review? We didn't do all of them, but we did enough of them. All right, so everyone understand what we have today. We've got at the end of class, so in 3 minutes, theoretically, we'll see, the chapter 10 quiz should open up. I think there's 3 questions. You need to turn that back into me by uploading it back to me by noon tomorrow, I think. Then I'll grade it, get it back to you sometime tomorrow. Then on Wednesday, we'll have a short class, no more than 45 minutes. So from 4 to 4:45, we'll have class. At 4:45 on Thursday, theoretically, test 2 should open up. You should be able to download that, and you can work on that and turn it back into me by noon on Thursday. And it'll work just like the last quiz, chapter 7 quiz worked. All right, is that fairly clear or not?
Yeah.
Okay.
Yes. Did you say there will be a question or two about trading currencies?
If there is, it will follow just that stuff we did before.
Okay.
I may not, since we didn't have a chance to review it, but you can look it over and we can talk about it on Wednesday if you want. We'll have a little time on Wednesday. But yes, there could be, if there are questions, it'll be 1 or 2 questions from the non-chapter trading currency. All right. Anything else? All right. Well, if you have questions, just, oh, someone sent up, can you explain 9B one more time? Maybe. I think this meeting could. All right. Nine B, will covered interest arbitrage work for a New Zealand investor with 100,000 New Zealands to invest? No. The reason is that if they take New Zealand dollars and convert to US dollars, okay, and then invest for 1 year, they'll earn 3.6% on the US dollar, okay, which is more than 3.1% they could earn locally. Okay. So they'll pick up about 0.5%. Okay. But they're going to eventually have to, unless they travel to the US, which doesn't make sense. But anyway, they're going to eventually have to convert them back after 1 year. Oops, wrote that one. They're going to have to convert 1 year later the US dollars back to New Zealand dollars. And when they do that, since the New Zealand dollar is selling at a forward premium, it means the US dollar is selling at a discount. So they're going to lose about 1.09% on the currency conversion. So if you're picking up 0.5% on the interest rates, but losing a little over 1% on the currency conversion, you're not going to be better off. In fact, you're going to be worse off. All right, does that kind of answer your question? All right, well, hopefully chapter, I forgot what it was. Chapter 10 quiz should be open. I'll go check it real quick and see. Chapter 10 quiz should be open, and you've got 20 hours to complete it. Well, maybe a little more, 20 hours and 43 minutes. All right, I'll see you guys on Wednesday.